Hello everyone, I am Mr. Ashok Kumar from VTU and AKLC. So in this video I am going to briefly explain you about the project, a novel approach for efficient accessing of small files in HDFS. So all I am going to do in this particular video is explaining you what actually this project does. I am not going to bother about how we are implementing this, okay, because you are just started to learn this project. You are not a master of it, so you will be requiring a lot of time to understand the implementation part of the project, okay. So I request you people to go to your college coordinator and explain the project like the same way I am going to explain you in this particular video, okay. So definitely they are going to ask you one or more questions like, tell me more about the algorithm or tell me more about the technologies, etc, etc. So whatever questions they are going to ask you, so just promptly reply them saying that you just started to understand this project, you are not a master of it, so you will be requiring 1 or 2 days of time to answer those questions, okay. And all those questions your colleges are asking you, you people should be immediately redirecting it to me on this phone number, or you can type all those questions and mail it across to me on this email address. So I am going to answer to those questions immediately, and then you people can go back to your colleges and answer to them, okay. So these are the things that I am going to explain you in this video. Firstly, I will be taking you people to something called quick facts about this project, and then I will be explaining you some prerequisites that you need to know before you understand this project, and then I will be stating the problem like what actually we are solving in this project, and then I will be explaining you the existing systems available to solve that problem along with their drawbacks, and then I will be telling you what actually the system we are proposing along with its advantages, and at last I will be taking you to software and hardware requirements. So firstly, to come to the quick facts about this project. So quick facts are something that you need to be ready with the answers to these questions at any point of time. So because even your colleges or externals or whoever it is, at any point of time they might ask you these common questions that you need to be ready with the answers at any point of time, okay. So firstly, they will be asking you the base reference, like where did you get the idea from, what actually what is the paper that you are implementing. So the base reference for this particular project will be an IEEE 2016 transaction paper, okay. So we are implementing the latest IEEE paper on available. So the domain of this particular project comes under big data. So the algorithm or the technique, the core algorithm that we are going to use in this project will be TLB map file, okay. So do not worry about the working of this algorithm. So you just have to mention the algorithm name, because the detailed implementation you will be learning only in the project classes, okay. So expansion for TLB, you need to remember it's a fast table structure, so we call it as fast table structure, okay. So the platform, like what is the environment in which your project is running, okay. So the environment in which our project will be running will be obviously the Hadoop, okay. So we will be using the Hadoop platform. So either we will be using there will be a virtual machine, we also call it as a sandbox, okay. So we will be using this virtual machine or sandbox to run our project, okay. So we have one popular Hadoop sandbox provider called Hortonworks, okay. So we will be using this Hortonworks sandbox to run our project, okay. So and then the amount of lines you are going to write in this particular project, okay. So in this particular project you need to mention that we are going to write around 3000 to 4000 lines of code, okay. So on an average a VTU student will be writing only around 1000 lines of code. You can compare our project with any other institute project or any of your seniors project like that. So the entire project will be completed within 1000 lines of code itself, okay. But in this particular project we are going to write around 3,000 to 4,000 lines of code. That doesn't mean that the project is complicated or something like that. So each and every line of code that you are going to write will be given a justification. It will be easy to write, it's not a problem, okay. So and then they are going to ask you the percentage of database you are going to use. Okay, the reason why I have put across this point here is because VTU have a restriction on the amount of database that we can use. So VTU strictly say that every project should be using lesser than 20% of the database. Okay, so VTU doesn't allow more than 20% of the database. Okay, so in this particular project we are going to use only around 3 to 4% of the DB. Okay, so we are not going to use more amount of database. So this is not a database project, so just tell them clearly we will be using only 3 to 4% of the database, and at last, after we complete developing the project, we will be proving that we are using only maximum of 4% of the database. Okay, so if you look at this particular quick facts, the reference paper is a 2016 IEEE paper, domain is big data, and the core algorithm is TLB map file. The platform we are using is Hortonworks Sandbox, and the lines of code and the database. So all these things are the are the strong points in your project. Okay, so these things will be adding lot of values to your resume. Now coming to the prerequisites about this project, as I told you earlier, so before you understand this project you need to know something else. So to be more clear, so you have to know the concept of big data, and you have to know the concept of Hadoop. Okay, so these are the two things that I would be explaining you as part of this particular slide is concerned. Okay, so not in the detailed part, so just a basic introduction about the big data and Hadoop. So here I'll be giving you an introduction to big data and Hadoop. Okay, so I'm not going to explain you in detail about these things, so you will be understanding each of them in detail in the project implementation classes. Okay, but as far as this video is concerned, I'll just give a small introduction to these two things. Okay, so coming to the first part, big data. As the name itself will indicate, big data is something that is huge, or we can say that large amount of data, we call it as big data. Okay, so one fact that you have to know about big data is from the start of the year where we started to collect the digital data, or say for example from 1945 to 2012. Okay, from the start of the year where we started to collect digital data till 2012, we have collected only 10% of the data. Okay, so whereas from 2012 to 2016, current date, so we have collected around 90% of the data. Okay, so if you can see these particular statistics, we can come to a conclusion that over the past 4 to 5 years, so the amount of data we are collecting, digital data we are collecting, have tremendously increased like anything. Okay, so and also in the next 10 to 20, couple of decades, so the amount of data will be even more than this. Okay, so this is the recent trend. So analyzing the huge amount of data, so it's something challenging and something where the corporate industry will be expecting a lot. Okay, so definitely these projects on big data domain will be adding a lot to your resumes. Okay, so now the question is where actually this huge amount of data is coming from. Okay, so you can answer this question to yourself, where actually this huge amount of data is coming from. Okay, so one example I can give you is social media. Okay, so how social media like Facebook, LinkedIn, Snapchat, Instagram, Twitter, so all these things have grown over the past 4 to 5 years. So 5 to 6 years before, the amount of data collected by Facebook or LinkedIn was not that huge, but over the past 4 to 5 years, these social media produced enormous amount of data. Okay, so one blog says that for in a single day, Facebook itself will be providing you 1 terabytes. Sorry, Facebook itself will be providing you 100 terabytes of data in a single day. Okay, so that's the amount of data Facebook will be providing you for one single day. Okay, so and another source of digital data will be called e-commerce sites like Flipkart, Amazon, Myntra, Tesco. So all these things also will be providing huge amount of data, and lot of hospital data like DNA, report, patient health information, etc., So these are the sources of data where we have, and there will be Data will be everywhere in every organization. Okay, so these things resulted in huge amount of data that has been collected over the past 4 to 5 years. Okay, so the problem is what, so we have collected this huge amount of data, but we don't have capability for processing this data. So that's the fact. So we are collecting this huge amount of data, but we don't have that capability, easiest way to process the data. So what is the reason for collecting the data? Because it will be used at some point of time in future, but we are not able to process that data easily. Okay, so that's the problem in big data. Okay, so as a solution for big data, so the lot of technologies have come, NoSQL databases have come, Hadoop is one such solution. Okay, so let me take you people to the concept of Hadoop. So I think you people have pretty much information or very small introduction to what big data is actually. Okay, and what's the problem we are facing in the big data. Okay, so as I told you a few minutes before, Hadoop is one such solution for solving the problem that we are seeing in big data. Okay, I'll repeat it. So the problem we are seeing in big data is what? We have collected huge amount of data and we have stored it, but we don't have easiest way, or we don't have capability to process that data easily. Okay, so Hadoop comes as one of the solution to store that huge amount of data and process that huge amount of data and come up with important results. Okay, Hadoop can be used for processing huge amount of data and generate various reports that will be helpful for an organization. Okay, so whenever you say think about this term Hadoop, okay, two things should come to your mind. Number one, HDFS, and number two, MapReduce. Okay, so these are the two things that should come to your mind whenever you think about Hadoop. Okay, I'll be explaining you what is HDFS and I'll be explaining you what is MapReduce. Okay, but before that I'll just give you a one-line information about these things. Okay, Hadoop provides the capability to store the data and process the data. I'll repeat, Hadoop provides the capability to store the data and process the data. Okay, so HDFS will be used to store the data, whereas MapReduce will be used to process the data. As simple as that. Okay, so Hadoop provides the capability to store the data and process the data. So how will you store the data in Hadoop? Use HDFS. How will you process the data in Hadoop? Use MapReduce. Okay, so now I'll be giving you more detailed explanation about the HDFS and MapReduce. Okay, so how actually Hadoop will be storing the data? Let us understand how actually Hadoop will be storing the data. But before getting into HDFS, I just want you people to learn this particular use case that I'm going to give you right now. Okay, so imagine that I will be giving you 1 GB of file. So if you can see here, I'll be giving you 1 GB of file and I'll be asking you people to copy this 1 GB of file, okay, into a machine having 2 Mbps rate of transfer of 2 Mbps. Okay, that means that this laptop will be capable of copying 2 MB per second. So what will be the time taken to copy this 1 GB of file into this particular machine? Okay, so the calculation is pretty straightforward. For 1 second it will copy 2 Mbps. So how many seconds you need to copy 1 GB? So it will be 500 seconds, right? So it will be requiring 500 seconds to copy 1 GB of file into this machine. 500 seconds will give you 8.33 minutes. Approximately it will be like 8.33 minutes you are going to take to copy 1 GB of file into this machine. Okay, so now I am going to ask you to reduce the time taken. How will you improve this particular performance? So 8.3 minutes to copy 1 GB of file is pretty huge. So I want you people to reduce the time taken. Okay, so what can be done to reduce the time taken? So instead of copying 1 GB of file into one machine, so I'll be getting 5 different machine and I'll be partitioning that 1 GB file into 5 pieces like this. Okay, so this is the first piece and this is the second piece and this is the third piece and this is the fourth piece and this is the fifth partition. Okay, so one single file I have made that into 5 different partition where each partition will be of 200 MB. okay, and each 200 MB will be copied to a different machine, remember, parallelly. Okay, so we will be copying 200 MB each partition we will be copying into different machine parallelly. Okay, so what will be the time taken now to copy 200 MB into one machine? So it's 100 seconds. So 100 seconds will be around 1.66 minutes approximately. Okay, so one machine will be taking 1.66 minutes to copy one partition. Remember, we are copying all the 5 files parallelly, so overall time taken to copy 1 GB of file is still 1.66 minutes. Okay, compared to the previous way of copying the data where it took 8.33 minutes. So now the new technique that we saw here will be taking only 1.66 minutes. Okay, so this is how you can improve the performance, rate speed. Okay, this is how you can reduce the time taken. Okay, so this is the core idea behind Hadoop. So this is what we call HDFS. This is how Hadoop will be storing the data. Okay, if you give 1 GB of file to Hadoop, how it's going to store, it's going to divide that 1 GB of file into some n number of partitions, and each partition will be stored in a different node. We call it as a data node. Okay, so because the data will be stored in a different machines or different nodes, we call that data is distributed. It's not present in a single machine. Data will be distributed. Okay, so that's the expansion for HDFS. Okay, HDFS means Hadoop Distributed File System. I am going to write here. We call this as Hadoop Distributed File System. Okay, so this is how Hadoop will be storing huge amount of data in a faster approach. Okay, so now we understood how actually Hadoop will be storing the data in HDFS. So to retrieve the data, to process the data, we have something called MapReduce. Okay, so you cannot learn the entire MapReduce as of now, but I want you people to just remember that MapReduce is a program. Okay, it's a programming language. MapReduce is a program using which we can retrieve, using which we can process the data stored in HDFS. Okay, so if you have stored the data in Oracle or MySQL, how actually you are going to process it? You are going to write one line of query like select star from student or select star from employee, etc., etc. Okay, like that. Instead of writing one line of query in Hadoop, you are going to write one big program itself in MapReduce. Okay, to process that data. Okay, so these are the things that you want to understand before we get into the project details. Okay, so I would like to summarize it again. So big data is something, huge amount of data. So the problem in big data currently we are facing is what? We are not able to process the data efficiently. Okay, so Hadoop is one such solution to store huge amount of data and process that huge amount of data. So Hadoop basically comes with two things, HDFS and MapReduce. So using HDFS we can store huge amount of data, and using MapReduce we can process that huge amount of data. Okay. Okay, now let us come to the problem statement. So here I will explain you the problem that we are trying to solve in this particular project. Okay, but still, because you are very new to big data, it will be a bit difficult to understand the problem statement clearly, but I'll try to explain it in an easier way as I can. Any questions you still have, please feel free to call me or email me. Okay, so I can say that the problem that we are trying to solve in this particular project is small files problem in Hadoop. Okay, in the prerequisite, you people have learned that Hadoop is a wonderful solution available to solve the big data problem. Hadoop allows provides us the capability to store the data and also to process the data. But for small files, for large number of small files, Hadoop has a drawback. Okay, I'll explain you what is that drawback. Okay, so that is the problem that we are trying to solve in this particular project. Okay, so in the prerequisite you learned that if we input 1 GB of file to Hadoop, it's going to partition that into say 200 MB into 5 files. Okay, it's going to divide that 1 GB of file into 200 MB file, and each 200 MB will be stored in a separate machine, in a separate node. We call it as data node. Okay, that separate machine we call it as data node. Okay, so but within each data node, how actually the 200 MB file will be stored? Okay, so you need to understand the memory representation of Hadoop now. Okay, so assume that for one of the node we given 200 MB. So how that 200 MB will be stored within a single data node, we are going to understand. Okay, so if you look at this particular diagram, so this is the memory representation of Hadoop. Okay, so if that particular machine have say for example 500 terabytes of hard disk, so that 500 terabytes of hard disk will be divided into 64 MB blocks like this. Okay, so this will be the first block, and this will be the second block, like that. Okay, so and this will be the third block, and this will be the fourth block, like that. So the entire memory available in Hadoop is divided into 64 MB blocks now. Okay, so for this particular machine, if we give 200 MB of file, if we give 200 MB of file to this particular machine, how actually it will be stored? Okay, so this 200 MB of file will be further divided into 64 MB, 64 MB, 64 MB, and at last 8 MB. Okay, and each of these 64 MB will be stored in first block, second, third, fourth, like that. Okay, so this is how Hadoop data node will be storing the data given to it. Okay, so you can see in the last block, in the first block, all entire 64 MB is used, so the utilization is 100%. In the second block also the entire 64 MB is used. In the third block also the entire 64 MB is used. So we achieved 100% utilization in the first three block. Okay, but whereas in the fourth block you can see we have used only 8 MB of 64 MB. So utilization is not 100%. Okay, the remaining 56 MB gone waste. Okay, so tomorrow if somebody gives another file to store, we cannot reuse the fourth block. Hadoop will be starting to store that new file in fifth block onwards here. Okay, so this is the wastage that we are trying to solve. Okay, so but in this particular case this is not a huge waste. Okay, but this particular problem will be worst when we provide large number of small files as an input to Hadoop. Okay, so in the previous case we given 200 MB file, single file with huge amount of size. Okay, but now we are giving multiple files but small size. Okay, this we call it as large number of small files. Okay, so let us understand what happens in this particular scenario. Okay, if we give 4 files, Hadoop will be storing 2 MB in first block. Okay, the second file in second block, the third file in third block, and the last file, fourth file, in the fourth block. Because the file is just 2 MB, it cannot divide it further because the available block size is 64 MB. So you can fit in 2 MB easily inside 64 MB. Okay, so this is how Hadoop is going to store. Okay, so what is the result of this particular approach? In the first block we have wasted 62 MB, in the second block we have wasted 62 MB, third and fourth block we have wasted again 62 MB each. Okay, so now I can easily conclude that if we provide small files to Hadoop, okay, the memory efficiency is worst. Hadoop is only suited for huge amount of data. Hadoop is not suited for small files. Okay, so this is the conclusion that I can infer. I'll just repeat, Hadoop is best suited only for huge amount of data, but for small files Hadoop performance is worst. Okay, so this particular problem we call it as small files problem. Okay, and this small files problem happens to be our problem statement. Okay, so this is the problem that we are trying to solve in this particular project. Okay, so here I am going to explain you the existing systems available for solving the problem that we stated earlier, and also let us also mention their drawbacks. Okay, so just to recall, the problem that we stated earlier is the small file problem. Okay, so where we concluded that Hadoop is best suited only for huge amount of data, but for small files Hadoop performance will be worst in terms of memory. Okay, so for solving this particular problem, okay, I could think of two existing systems that are mentioned in the IEEE paper 2016. Okay, so the first existing system available is called HAR, and the second available system to solve the small file problem is called sequence files. Okay, sequence files is the technique available to solve those small file problem, and also HAR is the another technique available to solve that small file problem. Okay, so to expand HAR, we call it as Hadoop archive or Hadoop archive. Okay, so to be frank, you don't need to explain these existing systems, because existing systems are something that were already been done by the previous authors. Okay, we will not waste time in understanding the working of existing system. Okay, instead we have to spend some time understanding the working of proposed system. Okay, so here we will just mention the disadvantages of these existing system, because anyway the current IEEE paper, IEEE author have studied this existing system and he has already proved that these systems cannot be used. Okay, and the proposed system is something that will have a lot of advantages over these systems. Okay, so it actually doesn't make any sense to understand the working of this existing system. So we will just come to the drawback of these existing systems, but you have to mention what are all the existing systems available in your project. Okay, so to mention the drawback of the first existing system, that is Hadoop archive, so we can say the drawback is when HDFS tries to read this HAR file, okay, it has to read two index files and the data file. Okay, so in simple words, you just try to understand that HAR will be maintaining two index files, okay, and one data file. Okay, in its working, in the working of HAR file, it will be maintaining two index files and one data files. Okay, when we try to read the data from this technique, so it has to read two index files and one single data file. So the read efficiency of the small files is still very low. Okay, so this is the drawback of the first system. I will just mention that read efficiency of the small files is very low. Okay, it provides a solution for storing the small files efficiently, but reading that small files is still very low. Okay, so this is the drawback of the first existing system. Okay, and now coming to the second existing system, the sequence files. Okay, so once again, sequence files working you don't have to understand in detail, but the drawback of this sequence files is what HDFS can only retrieve the file content sequentially, and the reading efficiency is still low. Okay, so that means that if there are huge amount of small files, say 1000 small files, this technique will be reading the small files sequentially, one after the other. Okay, so if I want to read the 978th small file, okay, this technique will be reading from the file number 1, file number 2, file number 3, file number 4, like that it will sequentially read till 978 files. Okay, so this is the drawback of the second existing system. Okay, so I'll just mention that formally, when reading the drawback of second existing system is when reading the massive small files, I mean huge number of small files, HDFS can only retrieve the file content sequentially, I mean one after the other. Therefore the reading efficiency is still low. Okay, so this is the drawback of the second existing system. Okay, so here we understood the couple of existing systems available in our project. The first one is HAR, Hadoop archive, and the second one is sequence file. Okay, so HAR maintains two index files and a data file. Drawback of this technique is that read efficiency of the small files is very low. It only solves the storage space problem, but the read efficiency is still a problem. Okay, the second existing system happens to be the sequence files. So here the files will be stored one after the other. content of the small files will be stored one after the other. So to read the content, once again we have to process it sequentially. Okay, so if there are massive number of small files, like if there are 1000 small files, and if I want to retrieve the content of 900th small file, so HDFS will be retrieving the content sequentially one after the other. Okay, therefore I can conclude that reading efficiency is still very low here also. Okay, so this happens to be the existing system and their drawbacks. Okay, now coming to the proposed system, like what actually we are trying to implement in this particular project. So I can formally say that the technique, the system that we are trying to implement will be called as TLB map file. Okay, TLB map file. We are going to solve that the small file issue that I described earlier using the technique called TLB map file. Okay, so you need to remember the expansion for TLB. The author calls this TLB map file as fast table structure. So we are going to employ this particular method to solve the small file issue that I described earlier. Okay, so the advantages of the proposed system compared to the existing systems is that it's going to reduce the memory consumption. Okay, and the second advantage is that it improves the retrieval efficiency. Okay, so if you can see the advantages of this proposed system, it also improves the storage efficiency, and also it improves the reading efficiency. Okay, whereas the existing systems, both the existing systems read efficiency was very low, but we will prove that our read efficiency is better compared to the existing system. Okay, so you cannot understand the working of TLB map file as of now, so you just have to say that the solution is present in the IEEE paper. During implementation you are going to understand it completely and then start implementing step by step. Okay, so this is the proposed algorithm along with the advantages of this proposed algorithm. So now coming to the hardware requirements. So we don't need any specialized hardware to implement this project because this is a software intensive project. Okay, so we just need a machine with 1.6 GHz processor along with 4 MB RAM and a minimum of 40 GB hard disk. Okay, so this moderate configuration is more than sufficient to implement this project. Okay, so coming to the software requirement, so here I'll be explaining you the technologies that we are going to use in our project. Okay, so you can also call the software, software requirements as technologies used. Okay, so here I would divide this technologies used into two things, the front end part and then the back end part. Okay, so in the front end we are going to use HTML, CSS, JavaScript along with jQuery and Twitter Bootstrap. So these are the technologies we are going to use in the front end, and in the back end we are going to use Java, core Java, advanced Java, J2EE. So when I say J2EE, it's JSP, Servlet and JDBC. Okay, along with MapReduce programming. So these are the things that we are going to use with backend, and other tools that we are going to use. Tools we are going to use will be Eclipse, IDE, Apache Tomcat server, and then Hortonworks Sandbox for providing Hadoop platform. Okay, so these are the other tools that we will be requiring in this project. Okay, so these are the detailed software requirement that we will be having in this project. Okay, so fine, thank you so much for watching this video. So once again, any questions or any concerns you have after watching this video, please feel free to contact me on this phone number, or you can mail me all your questions across this email ID. Thank you so much.